is that a real spacecraft?
No, it's a bit squashed, I'm afraid, as well.
British space
It's slightly squashed spacecraft. Okay, so how does it stay in orbit around the Earth? It's in free fall. Okay, it's under gravity. It's trying to fall towards the centre of the Earth in the same way that if we drop a tennis ball, it falls to the centre of the Earth. But what else do we know about the spacecraft? It's moving really, really fast, okay? More than 11 kilometres per second round that way, okay? As it's moving this way, it's falling. As it's moving, it's falling. As it's moving, it's falling. As it's moving, it's falling, okay? So, because it's moving really fast this way, and it's falling, as it moves round, it moves and it falls, it moves and it falls. So it stays in orbit around the Earth. That's how my spacecraft can stay in orbit due to the gravitational pull between it and the Earth. Okay? That's how the Earth stays in orbit around the Sun, because we're moving in an orbit, so we're moving really fast in one direction, and at the same time we're falling towards the Sun. So we're moving in circular motion like this. Okay, so this spacecraft has some people inside it, okay? You can't hear them, but they're in there. They'll scream when I do this, okay? Okay, as it falls, okay, as it falls, this is the picture of Phil as well, okay? This is Phil, and he's holding his scales, or he's holding his noisy toy, okay? When he fell, the scales fell at the same rate. When this falls, those astronauts are falling at the same rate.
Yeah.
So to them,
Yeah, makes sense.
to them, they appear weightless because they're moving at the same rate as the craft they're in is falling at. So therefore, they don't move relative to it. They feel weightless. Okay? So it's not that there's no gravitational pull there, because if gravity didn't exist out here, the moon would certainly no longer orbit us, would it?
And astronauts trained, aren't they, on that special aeroplane? I don't know whether anybody's ever seen that. Is it called Zero G or something?
Or the vomit comet.
Or the bonnet, yeah.
Because, so, who understands how things are in orbit a bit better than they used to? Fantastic. So it's in free fall, yes.
So what about when the rocket's moving away, so say towards the moon?
Right. So there's a gravitational pull between the Earth here and, can you pass me an orange? Okay. And the moon. Okay. How far's the moon away? Is it like here? Is it like here? Is it like here? If it was a picture in a book, it would be somewhere here, wouldn't it? Okay. That's probably. It's not quite over at the car park, but it's that sort of distance.
We've scaled this before, haven't we? Because
Yes.
the moon distance is actually, I think, about 10 Earth circumferences away.
Oh, it's 20, isn't it?
Is it 20?
I think it's 20 rather than 10.
Okay.
It's about that. Because if you took your globe there, your moon would be nearly at your cut. Your moon would be roughly at your covers.
Yeah.
I've got one set up with a bit of string.
Yeah. Is it 10 or 20
I can't
circumferences?
remember exactly what it is. I just get the one out with a
You
bit of
might
string.
well be right.
I think I am. It's not very often I'm right, but I think I am right here.
I think you are as well.
I think
I'm having
the
real
Earth's
doubts.
circumference is about 30,000 kilometres, and I think the distance
Four-
is about 400.
I think it's 40, because I looked at this very recently.
Circumference and diameter.
Circumference,
No,
yeah.
I'll tell you what, we'll look it up.
Okay. I'm going for 42,000.
In fact, we have measured this, haven't we?
Here we go.
You can measure it.
So the science.
The Earth's circumference is 40,000 kilometres. Well
Get
done.
in.
Okay.
What do
The
I want?
Earth to Moon distance.
You were thinking miles, weren't you?
Yeah.
Yes. Is 384 kilometres.
So it is 10. That was
So it's
10.
about 10 times. Yeah.
So I've got some. Well,
We're
listen,
good at that.
Anyway, so
No one's going to check it. No one's going to.
there's no witnesses.
the moon is gravitationally attracted to the Earth, okay? But it doesn't just fall in because it's travelling at fast velocity in this direction. Okay, but also if you're on the moon, those astronauts were sticking to the moon, okay, less strongly than we're sticking to the Earth, okay? They're attracted by the moon's gravitational field. So if you're close to here, you're attracted to the moon. If you're close to there, you're attracted to the Earth. So there's some point at which there's a balance between being attracted here and being attracted there. Okay? It's not because gravity doesn't exist there, it's because the gravitational force in that direction equals the gravitational force in that direction. Did that answer your question?
Sort of. So would it sort of like, would they, on the way to the moon, would they experience different sort of, would they feel more weighty on some days than other days, or will they always feel the same?
So it stops out at 9.8. Okay. Okay. Starts off at 9.8.